Now we've been looking at Bernoulli equations and V substitutions. Now if we have equations that are non-Bernoulli and non-separable upon original presentation, okay, now let's say if we have, as a case, we have x times e to the 2y dy over dx is equal to 4 times e to the 2y plus x cubed. And now while the equation is not linear, if you notice that we have in y, okay, we have on both sides, okay, we have e to the 2y, and what we can do is create a scenario where, knowing that the derivative of e to the 2y leads to a multiple of e to the 2y, and since we have e to the 2y as the only entities that we have in the variable y, we can do a special v substitution, whereupon we can say that we have v is equal to e to the 2y. And if I take the derivative with respect to x, so I'm going to have dv over dx is going to be equal to 2 times e to the 2y dy over dx. And now if you notice, we have in the equation, now we got e to the 2y dy over dx, and here dv over dx, I have 2e to the 2y dy over dx. So just keeping in mind, so I'm going to have 1/2 of dv over dx is equal to e to the 2y dy over dx. And if I look at substituting, okay, so we have for x times e to the 2y dy over dx. Well, guess what? If I put what I have in terms of substituting, okay, so I have e to the 2y dy over dx is going to be 1/2 of dv over dx. So I'm going to say that I'm going to have 1/2 of x dv over dx, and for 4 times e to the 2y, well, I have v in place of e to the 2y, so I have 4v plus x cubed. And so I have just sort of cleaning things up here. Let's say that if I take care of the coefficient 1/2 of x, so if I just multiply by the reciprocal of x over 2, which is going to be 2 over x. So I'm going to have in the rewrite dv over dx is equal to 8v over x plus 2x squared, and setting this up like a first order linear equation for what I have in the substitution variable v. So I have dv over dx minus 8 over x times v is equal to 2x squared. And notice, okay, for what I have for the first order v term coefficient, that is going to be negative 8 over x. So I'll just call this rho of x is equal to negative 8 over x, and providing an integrating factor so you have like e to the integral of negative 8 over x. And guess what? That's going to be e to the negative 8 times the natural logarithm of x and the integrating factor is going to reduce to the reciprocal of x to the 8th. And if I take this and multiply what I have in the equation that I have laid out in standard form, so for the substitution variable, and 2x squared over x to the 8th, that's going to be 2 all over x to the 6th. And for what I have on the left hand side, so I'm going to have the derivative in x, the integrating factor times the dependent variable. Okay, so I'm looking at v all over x to the 8th and I have is equal to 2 all over x to the 6th, and integrating with respect to x on both sides. So I have v over x to the 8th is equal to the integral of 2 over x to the 6th dx, and that is going to be equal to like negative 2/5 of x to negative 5 plus c, and by then you can just write this as negative 2 over 5 times x to the 5th plus c, and getting v by itself multiplying by x to the 8th. So we're going to have negative 2/5 of x to the 3rd plus c times x to the 8th. And looking at what we had substituted v for, again, that was for e to the 2y. And if I take the natural logarithm of both sides, so we're going to have that 2y is equal to the natural logarithm of negative 2/5 of x cubed plus c times x to the 8th. And so we have, in solving for y, dividing by 2, so we have y is equal to 1/2 of the natural logarithm of negative 2/5 x cubed plus c times x to the 8th. And notice I can make this coefficient into an exponent, and considering that the order of 1/2 is referring to a square root, I can also write this as the natural logarithm of the square root of negative 2/5 of x cubed plus c times x to the 8th. And another way, if you notice, we have raised powers of x, so I could factor out x squared, or the square root of x squared, which will go to x. So I could also write this as the natural logarithm of x times the square root of negative 2/5 of x plus c times x to the 6th. Now, another case of an equation that is neither Bernoulli nor separable. Now we got 3y squared dy over dx is equal to 4y cubed plus 7x. And again, if you look at what we have in y, okay, we have y squared and y to the 3rd. And if you note, okay, we have on the side next to the derivative dy over dx, we have y squared. And now, if you notice on the other side, we have y to the third. And acknowledging that we had the derivative of a cube in y, taking the derivative with respect to y is going to lead to y to the second. We can apply a substitution variable v and set this equal, and we'll say to y to the third. Okay. And if I take the derivative with respect to x on both sides, so I'm going to have dv over dx is equal to 3y squared dy over dx and if you notice, we have an identity. Okay, so we have in the rewrite for 3y squared dy over dx, okay, we have dv over dx, and 4y cubed, that's going to be 4 times v. Then we have plus 7x, and writing with the substitution variable terms on the left hand side. So taking 4v away from both sides, notice we have dv over dx minus 4v is equal to 7x. And taking what we have now for rho of x, that is equal to negative 4. And for the integrating factors, I have e to the integral of rho of x dx. That's equal to e to the integral of negative 4 dx. And that is equal to e to the negative 4x. So upon looking at multiplying the terms out by e to the negative 4x, and on the right, we're now going to have 7x times e to the negative 4x, and the left-hand side of the equation. Okay, so that is going to be the product rule expansion of multiplying the integrating factor, which we have with e to the negative 4x, times the dependent variable, which we have with the substitution v. We have is equal to 7x times e to the negative 4x, and integrating with respect to x on both sides. So we have e to the negative 4x times v. This is going to be equal to the integral of 7x times e to the negative 4x dx. And this is one of those where you're looking at integration by parts. So just noticing, okay, so we have with 7x times e to the negative 4x dx. So we can say that we have u is equal to 7x, and we have du is equal to 7 dx, and dv we have at e to the negative 4x, and the antiderivative we have with negative 1/4 of e to the negative 4x. And for what we have in the follow-through, so for the u times v, we're going to have minus 7/4 of x times e to the negative 4x, and minus the integral of v du. So you have like minus 7 times negative 1/4 is negative 7/4. So you have a double negative, which revert to addition. And we have of the integral of e to the negative 4x dx. And we just changed from subtraction to addition, and we're going to go back to subtracting. So we have, in the terms, we have negative 7/4 of x times e to the negative 4x. And what is going to be minus 7/16 of e to the negative 4x, followed by the constant. And going back to our equation, so we have e to the negative 4x times v is equal to negative 7/4 of xe to the negative 4x minus 7/16 of e to the negative 4x, followed by the constant. And if we isolate v, so we have negative 7/4 of x minus 7/16 plus c times e raised to the 4x. And again, I had substituted v for y to the third. And so we can leave the results in the form of where we have y cubed is equal to negative 7/4 of x minus 7/16 plus c times e to the 4x. And also another way, if you were to isolate y, you could take essentially the cubic root of this expression or where we had the quantity of this 3-term expression raised to the 1/3 power.